final grant on the interactive internal combustion simulation.
Hi everyone, good afternoon. I don't have anything that's working yet, so I'll talk about the motivation for this work. And I think it's a problem that's quite common in engineering classes, and that is that students learn material for a topic, and it can be quite dry. And if the class doesn't have a lab, they end up just reading through a book, something that has very significant applications in the real life world, but they never experience it through that class. So I came here last year, and just this past fall, I created or introduced a class here that used to be taught at the University of Michigan, where I came from, and that was a class on internal combustion engines. So I had a lot of material. I started, put everything together and started teaching the class. So internal combustion engine, the topic itself, the engine is a very complex system. And it's a good senior level class or entry-level master's class, because it combines a lot of stuff that the students should have already learned in the previous graduate career. You can talk about thermodynamics, heat transfer, and then you can introduce topics about combustion, turbulence, and so on. And as such, immediately you see that you start talking about so many things, it's good to put them in practice. So the engine itself, the operation of an engine is affected by a lot of things. The geometry of the engine, how big the bore is, how far the piston moves, the stroke, as we call it, and so on. And also operating parameters. What is the engine speed? When does the valve open? When does the valve close? When is the spark plug fired? And so on. So you teach everything in a class like that, and ideally you would also have a lab to support this course. And back in Michigan, we did have a lab to support this course. And the lab usually consists of an engine and a dynamometer setup. So what this means is you have an engine on a test bed that's connected to the dynamometer, and what the dynamometer says. Can we break down the word dynamometer? Right? It's force and meter, right? Meters measures the force. Basically, it breaks the engine, doesn't let the engine speed up, and you can measure how much power it's generating. And of course, you need a whole bunch of sensors, all these cables, wires that you see there. They connect to thermocouples and pressure transducers and so on. But this is not just it. On the other side of this room, you have the control room, right? And this will have an engine dyno controller. It will have a data acquisition system. It will have an emissions bench that measures what emissions come out of the engine. And this is all very nice and good, but the cost can be pushing $1 million. And of course, not every university, not every class can have a lab like that associated with the class. So, of course, when I came here, there's absolutely no engine work being done. So there was no facility that could be used. And I decided to teach the class anyway, but then throughout the course I realized that something was missing. So the idea was, well, what do you do if you don't have an engine lab? Well, you create a virtual engine lab, right? And basically, my motivation was to offer the students something that they can use on their computer and well, somehow virtually live the experience of having an engine and controlling it on the fly and see how it behaves. And there are simulation tools available, commercial tools, but they're expensive and they have a very steep learning curve. I wanted to give them something that can be used very easily by just someone who's taking the course without any prior knowledge of software. And of course it has to be something that can just run on any computer. Ideally it could be available on sync sites, and they could also run it on their own computers. Kind of like what Anurag showed, but not expensive. So the platform that I chose, because that's what I'm familiar with, is MATLAB, and basically we want to create a GUI blade-based application that can run in the background. A very basic engine simulation that I have created. but the students would just see the front end, which is this GUI, which basically consists of the dyno controller on the left, where they can set the parameters for the engine speed, valve timings, the spark timing, and all the different parameters that they want to control. And then they would have their data acquisition system on the right. So as I said, this is still work in progress. They would have real-time diagnostics in these charts, where you can see the pressure, the temperature, and so on, and some other key values in the end, on the bottom of the table. So the idea is they would click the start their engine, and they can change variables on the fly. These windows will record the previous value, so they will see how one curve moves to the next level, and there will be some memory effect, so they can see the effect for a while on the screen, and then when they arrive to a point that they like, or that they had to visit, an operating point that they had to visit, that they can click a button that saves the cycle, so it will save all the inputs and all the outputs, and then they can process for a report or to study further. So it was something as simple as that, and the one thing that I didn't know much about was writing MATLAB GUIs. We have a student, I do have a student out there that works with me and helping out with the GUI. The engine simulation and professor that teaches a class has the knowledge to write a basic computational tool that addresses some very key problems for the course that's being taught. It's just a matter of taking the time and creating something like that. The way I envision using this would be either for in-class demos, as I said, giving it out to the students just to play with it, but also creating assignments based on this tool that they can, as I said, instead of running the lab, just use this to study certain effects and understand them and discuss them. So it's simple like that. Unfortunately, I'm leaving. So it won't be used next year because I decided to actually go to the industry myself and practice these things. So, but hopefully the person that takes over can use it. So, but as I said, this is something that applies generally in engineering education. And I'm nervous doing it. I try to do it, and it just should be done more often. So, thank you for your attention. If you have any questions about our work, I'll be happy to answer.